Welcome to Laurier's Teaching Excellence Conversation Series. I'm Deborah Van Eyneton, Academic Director of Teaching Excellence and Innovation at Wilfrid Laurier University. Today, I'm with Hind Al-Abadleh from Laurier's Chemistry and Biochemistry Department, who received the 2023 Hoffman-Little Award. The Hoffman-Little Award recognizes faculty for excellence across their professional lives as teachers, researchers, and disciplinary scholars. It also distinguishes faculty who inspire, serve, mentor, and lead their students, colleagues, and are active in the wider community. Hind is a leader in chemistry education, helping her students connect the dots and weave their learning between classes together to see the whole picture. She skillfully embeds active learning and applied problem solving in her courses and helps her students find professional skills that set them up for success throughout their lives. I'm excited to get to talk to her today about how she engages, mentors, and inspires her students and her colleagues. So one of the things that comes really strongly through in your package is that you have managed to really bring together your research life, your teaching life, and I would add also your service life, right? This is one of the biggest challenges I think that faculty face, right? How do you bring them together so that they're mutually reinforcing?
Right.
Can you talk a little bit about how you do that?
Yes, absolutely. I mean, I don't see boundaries between the teaching, the research, and the service. And because my research interests are in environmental chemistry, students come with pre-knowledge about and passion for environmental issues. So usually my job is to, teach them how chemistry, which is perceived by most people as a difficult subject to study, is actually central to our understanding of how the universe works, how nature works, and how human activities affect the chemical balance of natural systems. So the courses I teach highlight chemistry fundamentals, and then the application of chemistry to solving environmental challenges and the opportunities these challenges present. So in my research, I do research in atmospheric chemistry, in geochemistry, and environmental remediation. And my goal is to highlight how we use chemistry principles to understand natural phenomena in the atmosphere, in water, in soil. But at the same time, once we recognize that there are problems like pollution, how chemistry can help us solve that problem. So this is where the remediation parts come into the research. And in my classes, I connect everything together because the students need to see why they have to struggle with mathematics and learning very difficult.
And I've got a question about that too, but yes,
and they're very difficult subjects that they seem very abstract at the beginning, but when you actually link the research and then you show them that this knowledge was instrumental for this paper to get published, for this student to graduate and get hired by this company, then it starts to make sense for them. And then for service, absolutely. I mean, the Chemical Institute of Canada has multiple divisions that are related to the very fundamental classical branches of chemistry. And the environmental division is by its nature multidisciplinary and interdisciplinary.
So there's an environmental section there too.
Oh, yes.
Okay.
And it gathers.
All right. So everything comes so nicely together.
Oh, absolutely.
Okay.
Yes.
Wonderful.
Yes.
Well, I'm just going to pick up on something you just said because your nomination package does make clear that you teach tough courses, and your courses have a reputation for being hard, right?
Yeah.
Very math heavy.
Yes.
So how do you bring students in?
Right.
How do you help them kind of struggle through those difficult things? Like when I was looking at your course descriptions, I was like, oh wow, right? Yeah. So how do you bring students in and get them excited and also support them through that?
Yes, so it starts with the textbook. I surveyed a lot of textbooks, and I made sure that I choose one that is written for undergraduate students, that it has reinforcement of mathematics throughout the book, that emphasizes problem solving and critical thinking, and it has a student solution manual. So the book and the student solution manual serve as the second instructor in my absence. During lecture time, I reinforce the analytical problem solving parts of the book, and I encourage the students to go and spend time with the book to read more, so that they complement what happens in the lecture versus what they read in the book. And my classes have a tutorial session too. And in tutorial, we do additional problem solving exercises.
Right.
And
right.
we do revisions of the math the students have learned. And the other thing I've implemented was the assessment scheme. So instead of assessing students twice a semester through a midterm and a final, I assess them through smaller quizzes throughout the semester.
Yes, yeah.
And this way, they slowly improve. They slowly see that their skills are improving.
Yeah, they're smaller, lower risk assignments to build confidence.
Exactly.
Absolutely. Yeah.
And the other thing that I found helpful is actually the analogy with playing video games and for training for the Olympics.
Oh, okay.
Yeah. So what
you have to talk about that. How do you use these analogies?
Exactly. So I tell them, look, I'm sure that you are playing video games or you have played video games. The way video games are designed is that you spend a certain amount of time on a certain level till you score the maximum points, and then the game automatically takes you to level 2.
Yeah,
which is harder than level 1. And then once you master level 2, you go to level 3.
With this. Yeah.
Imagine that this game does not have levels of difficulty. So what do? You master level 1, and then you'll get bored and you'll just leave it. And the game has to hook you to go to multiple levels, and it increases in difficulty, and the gamer doesn't mind the increase in difficulty. Same with training for the Olympics. Athletes train 3 to 4 years for a competition that takes minutes or hours. And do you think I tell them that these athletes go to the Olympic Games with no training mentally and physically to be ready for these games? So you need to think of learning the hardest parts of chemistry as you are training a brain muscle. You are training a brain muscle, you build on previous knowledge you have, and with persistence, with gradual
levels.
Absolutely.
Right. And so do they like that? Do they buy it?
They get amazed that there is an analogy, and that gives them a sense of patience with themselves. Right. I think that the students they just rush conclusions.
Yes.
Instead of giving themselves the pace to say that it's a learning process. There will be moments of triumph because it builds on what you already know, but there will be challenging moments because you need to learn something new. You cannot just continue.
And it might be really hard.
Exactly.
Yeah. It's funny because students, they want the answer.
Oh, yes.
Right. They want black or white.
That's right.
And so learning to persist in terms of applying, over the longer term is, that's something that I think we teach them, right? When they get to university.
And the other thing that I found also useful was YouTube videos. YouTube has an amazing selection of scientific content that actually traces back the history of science and demonstration of chemical processes, physical phenomena. And they're usually not too long. They can fit within a lecture time or part of a lecture. And when I show these videos, tell them, see, this is how scientists think.
Yeah.
Things do not come overnight. They build on previous knowledge, and then they do new experiments. And then when they find that they cannot explain new stuff with the knowledge that they already have, they don't give up. They start making new stuff, new laws, new equations. And that's why we need the power of mathematics to help us translate, chemical knowledge into mathematical knowledge.
You and I both share in our research lives and our teaching lives concern about the environment. And you mentioned that a few minutes ago.
Yes.
Do you find that environmental concern and a focus on environmental problems helps you hook the students into material that might be difficult?
I do, because, for example, when we talk about climate change, and I tell them, okay, let's just talk about climate change. Climate change, it's all doom and gloom, depending on who you talk to. And then, but do you think, where do we get the information about the doom and gloom? It's actually from climate models. Do you know how climate models work? They're a bunch of mathematical equations that are run on a supercomputer But then where did these equations come from? It came from our very fundamental understanding of how nature works, how the different components of the atmosphere affect the energy balance of the atmosphere. So our ability to translate fundamental understanding into mathematical equations help us build complex models that help us project the future. And of course, these models will have uncertainties in them. That's why there are experimentalists who work in the lab, and there are specialists in computer models. And we work together. The computer modelers tell us what type of experiments we need to do so that we improve the predictive power of the models. So I use that as an example to show them how mathematics is powerful. It is powerful because it gives us the ability to predict the future, even with uncertainty.
And so do you look at some of those models with them so that they can see how it works?
Sometimes, depending on
I know, probably not at the introductory levels. Yeah,
Exactly.
yeah.
But at least they will have an appreciation for where the math is going.
Yeah. And in terms of where the math is going, when it gets difficult, how do you keep them going? Right? So you
Yes.
talked a little bit about, some of these analogies that you give them, but how do you keep them going?
Yeah.
It's November.
Sure.
They're tired.
Yes.
Stuff's hard,
Right.
but it needs to be covered, right? How
Yes.
do you kind of
Yeah.
support them through that? Is that through tutorials or exercises in lecture?
Exactly.
Yeah.
It's a combination of everything.
all of
Yeah. I mean, there is no one, one recipe, honestly. What I found what works is that there are, because we have multiple styles of learning by the students. One has to implement multiple ways of teaching. And, doing exercises with the students help. I actually slowed down in November and I emphasize problem solving more because the material does get harder.
Application.
Yes.
Yeah.
It does get harder by November, and at the same time they're tired and they have other exams and other things. But and that's why with November I try to pace myself such that every single lecture will have maybe 30, 40 minutes of new material and another 30, 40 minutes of just problem solving and exercises and applications and reinforcement of the new material on the same day in the same sitting.
So can you talk a little bit about that, because that's really interesting. Are they in groups? Are they working on their own? Are you in a lecture hall? Are they moving around? How do you do that?
So my physical chemistry classes start in second year. So their enrollment usually goes from 40 to 60, and third year classes range from 15 to 10 to 15.
This is doable.
Very doable.
Yeah.
And the way we do exercises is that I open the floor. I give them time, talk with each other, or if you prefer to work by yourself, that's all fine. That time, that's the silence time, it doesn't have to be silent because there are students who prefer to talk with their neighbors, students who prefer to work by themselves. And then this time is the students' time. They get to do whatever they want. They will have access to their computers, their calculators, their phones, or whatever. And then I walk among them. I actually see what they're doing and how they're solving and
make sure they stay focused on task.
Exactly. and then once everybody, at least they see that there is some some movement happening in an advancement happening in how they're approaching the problem, then we solve it as a group on the board. Or I ask one of the students who have finished early, for example, to come and have this peer instruction, which I find very helpful, that they listen to their peer sometimes more than they listen to me. Yeah. So I try to involve students too who already, who are very advanced and excellent in what they're doing, to come and explain to their peers how how they have thought about a problem and how they approach it.
So is it similar in your senior classes then?
Yes.
That kind of thing?
Right.
How is your approach different?
Yeah, senior classes are different because in senior classes, the applications are heavier than the fundamentals, because by the time they get to fourth year,
they know the fundamentals.
Exactly.
So yeah.
But then what they're missing, senior students, is their ability to actually think at multiple scales, to go from the global to the molecular or from the molecular to the global.
Right.
So this critical thinking and multiple scales thinking is what we enforce in the large classes. And this is where I invite speakers from other disciplines to come and talk so that they can see how interdisciplinarity and multidisciplinarity work in addressing one topic. I also show documentaries that cover certain applied aspects that reinforce what we talk and where science fits in. Because water pollution and air pollution is a societal issue. Like if you talk about the ozone hole, for example, it was the activism on the ground that actually led governments to listen to the people and meeting
Absolutely.
the Montreal Protocol.
Absolutely.
And
Absolutely.
you see
Yeah.
what I mean?
That's actually one of the few international environmental success stories.
Absolutely. That's right.
Right?
That's right. Yeah.
The other technique that you use or approach that you use in your teaching is blended learning.
That's right.
So can you talk a little bit about that in terms of what do they do asynchronously before they come to class, and then you've got them doing things in
Sure.
class?
Yeah.
So maybe walk us through that a little bit.
Yeah, sure. So I applied actually two models of blended learning. One of them I tried almost 10 years ago, where it's a senior level class, listed as a graduate level, but it's a new topic for most students. Because, you know, in chemistry, we talk about the phases of matter, gas, liquid, and solid.
Yes, yes.
But this particular class talks about chemistry at the interface between different phases of matter. So the gas solid, the gas liquid, the liquid solid. So the chemistry is different.
So it's new territory.
Exactly, new territory. So I spent the first month giving them intense lectures to equip them with the fundamentals, the language, the techniques, and how their knowledge of the gas, liquid, and solid apply to the interface between different phases of matter. And then I transition to giving one lecture in one class, and them coming to deliver lectures on papers they have read related to the topic of the class, and then discovering that there are terms that they do not know, and then we take that as an opportunity to lecture on these new topics.
Okay, so they're preparing and looking for their own gaps, the gaps in their own learning, and then following up, right?
Exactly. And then towards the end of the semester, they have to critique a journal article and to give their expert opinion and act as if they were a reviewer for this manuscript.
Great.
And then they need to present about it, and because that will give them an appreciation for the fact that, you know, science is open to criticism, even if it's published.
Indeed, yeah.
Yeah,
that's right.
So we do that in that's one model of blended learning I do. The other model that I applied this year in a second year class that has about 22 students is to simulate how the Intergovernmental Panel Climate Change works.
Oh, wonderful.
So
they understand the complexity, the enormous number of people involved, the phases of review, right?
Exactly. Yeah. So I divided the class into smaller groups.
Oh, that's wonderful.
And each group is responsible for a theme or a project.
Yep.
And then they have to dig deeper into that topic with a focus on chemistry. And every single week, there is a rotation among the members of the working group. Each member has to contribute in writing to the group leaders, and the group leaders present a report and present an oral presentation. And then they have to write this author contribution section in their PowerPoint.
So that's wonderful experiential learning.
Absolutely.
Yeah.
And it was very well received by the students. And we've covered so much material that I do not think I will be able to cover in a single semester, you know, for a topic as important as atmospheric chemistry.
Well, and I think also because they're playing a part, they're drawing on all kinds of different knowledge to bring it to the table, right?
Exactly.
Oh, that's great. And in that class, do you start with talking about how the IPCC works and
Absolutely.
Yeah.
And most of them read about the IPCC from news articles, so it's not a foreign concept to them. It's just the inner workings and what the working group reports are, and why do they have multiple authors, and how the work gets divided.
And then the summary to policymakers, it's very political.
That's right.
Yeah. Wonderful. Okay, well, that's a lot of fun. I would see, I can imagine that the students would find that really relevant, right?
Oh, absolutely. I mean, the type of questions they ask are amazing because it really shows their depth of concern for environmental issues, and at the same time how they see that there is a role for them to play once they acquire the knowledge needed and they leave the university, for sure. Yeah.
You know, some of those neat things that you're doing in your class, it makes me wonder, are there things that you started during the pandemic and then you kept going, right? I think of all the things that were difficult with the pandemic and challenging and negative, right, in terms of teaching online, nevertheless, I think it moved us to try things we'd never tried before. And then there's some things that I have pulled kept in my teaching, right?
Right.
To integrate into in-person teaching.
Right.
So some of those things that you're trying, did
Yeah.
they originate during the pandemic, or is this post-pandemic or pre-pandemic?
It's actually all pre-pandemic. When the pandemic hit, I ended up creating videos for myself, lecturing on a whiteboard, because
Yeah.
I really wanted to simulate a real classroom for the students.
Oh, so you were working on the whiteboard
Absolutely.
and then, oh,
And I would
okay.
make mistakes, and I would use the eraser, and the students, I thought they would not pick up on that, but actually they
They
did.
loved it.
They loved it. Said, they said your videos were so engaging because we see you write and erase, and instead of a very static Zoom
Yeah,
meeting
exactly.
where you're
Yeah.
seated and the cameras are off, and your camera will be on, but you don't see except the black boxes on the screen. So I thought the videos, for them to see it before we meet on Zoom. And then we discuss the content of the video when we have the meetings on Zoom.
So that's blended learning.
Exactly.
That's wonderful.
Yeah, yeah.
Right? So they're coming prepared, and then you can do
Exactly.
more engaged activities
Exactly.
in the
Exactly.
classroom.
That's right.
Okay, that's really interesting.
Yeah, yeah.
It's I find that faculty across the university have really engaged with the technology post-pandemic in different ways.
That's right. That's
You
right.
know, some kind of pull it in and keep it, and
Yeah.
others are,
Yeah.
I'm so done.
Yeah.
I want to shift gears just a little bit and
Sure.
talk about your work in terms of equity, diversity, and inclusion. And it's really extensive and really impressive. And last year, you received the inaugural Gilead Award for Excellence in Equity, Diversity, and Inclusion from the Canadian Society for Chemistry.
That's right.
And you've been really active in this space, both in terms of your teaching, your service, your research. And I wanted to highlight the title of one of your papers, which I really thought was wonderful: The Centrality of Human Diversity to Advancement and Innovation in Chemical Research and Education in the 21st Century. That title to me was a vision.
That's right.
Right?
Yeah.
Talk about that vision that I see in that, I didn't read the paper, because I think I would find it difficult to understand, but, tell me what's going on with there with your vision.
Right, yeah. So the equity diversity work that I, started almost over 10 years ago was motivated by this vision, because, impacts of environmental issues touch people, they touch communities. And as a scientist who really knows the science, but then the impacts are usually said, all I have to do as a scientist is just do the work, publish the paper, and let it go. But I said, no. There have been a lot of polls out there to the general public about which professions the public trusts the most, and scientists came up to the top.
Absolutely.
And I was like, okay, well, I have that privilege of being a scientist, and therefore I have the privilege to train future scientists and also to influence how the public knows
and disseminate
that knowledge.
Yeah.
So I said, and because environmental issues touch different communities, I said these communities need to have the power of knowledge. And we need really to see, are they representative? Are members of these communities represented in the scientific community? And this is where this book chapter that you referenced was actually a critical look at the data. So I looked at the science majors across educational levels, across genders, with a focus on the chemical sciences in Canada. And the data showed that no, they're not. The immigrant community is not represented. Women were not represented. So there were gaps that really highlight an issue of how the scientific community works. And the second motivator was my own experience. I'm an immigrant to Canada. I spent time in the US as an international student. And therefore, the scientific community, how it works in the West, I got exposed to it as a graduate student and as a faculty member. So I could see there are problems in how we do science that turn off talented people with high potential from joining our
Talk about
communities.
that a little bit. That's really, these are really important things that we talk about, right?
Exactly. So, I think the highlight, there is a lot of research. I mean, this paper that you referred to has almost 90 references that actually talk about the psychology research and the social sciences research that looked into the reasons why there are certain members of certain groups do not find the scientific culture attractive and they just leave it. And I think it really gets distilled to access. The barriers are access to resources and access to the unwritten rules within the scientific community, and access to advancement and recognition opportunities. Research.
So how do we make sure that doesn't happen to our students?
Yes. So the way I have tackled it is by starting early. Like in my second year classes, I spend time of my lectures telling the students what do they know about a science career. Do they know how that the skills we're teaching them are really transferable and they can help them stand out in the job market? If they want to continue in science or not in science. I think what I have found is that there is a knowledge gap between really what a fulfilling science career looks like and how the training in science through the curriculum really helps them prepare for that.
Right.
And another gap I found is among students who did not go through the education system in Canada, who perhaps were immigrants to the country, and those students in particular are still unaware of how science works in the Western world. So that's why I make sure that this information is disseminated through my own example.
So you talk a little bit about your experience in classes.
Yeah, well, absolutely. Because what I share with them is that I was a chemistry major at one point. I
like
know.
you sitting in the class listening. Yeah.
So that's what I do. And then the other thing, there are students that I noticed who are shy, who are intimidated, who have faced perhaps racism and discrimination in their lives. Yep. But then the quality of their work shows, because I grade assignments, I grade quizzes and tests. And if I feel that there is a disconnect between how the student present themselves and how their work is showing, then I take special interest in those students. I ask for one-on-one meeting. I want to know more about them, their career goals, their professional goals. And then I ask them, do they know that these opportunities exist in the Western world if someone wants to pursue a career in science? And I walk them through it. So this is what I do at the student level. But for those who went through the system and became professionals, early career, mid-career, lifetime achievements, and who are women or underrepresented, in my role with different organizations like Nano Ontario or the Environment Division, I was very instrumental in creating these advancement and recognition opportunities that particularly recognizes, and they were very well received by most of the governance bodies of these organizations, and the award programs, I helped advocate for and create were very well received, and they're still ongoing. So.
Well, this is mentoring.
Absolutely.
So you're mentoring at all levels.
Exactly.
Right?
Exactly.
One thing that I would be very interested to know is that did somebody mentor you? Mm-hmm. Did you receive, good mentorship that you could then, kind of pass on down the line, showing you how to do it? Or is this something that you kind of had to do on your own?
Yeah, well, no, I was really lucky, and because I grew up in all girls' schools from grade 1,
So
through the K-12 system and undergrad education. And so I didn't grow up in an environment where I was told that there is no profession you cannot go to, because you didn't even have to ask. You had your teachers, the principals, everything who works in the school are women, right? You go out of the school, there are female doctors, female police officers, female bank, tellers in the bank. Everywhere you go, there are women who work. So I grew up with this mentality that I could be whatever I want. And that's why I actually changed what I wanted to do every single year when I was in school. And then in high school, of course, we get to choose between the arts stream or the science stream. And, I grew up in a culture where if you are an excellent student in all subjects, you should choose science, because science is where excellent students go. And
right.
that was implanted, from middle school into high school. And then so you go to science, and then you go to university, and then you meet professors who have been educated outside the country, who now share their own
experiences,
you know,
absolutely.
and research and being fascinated with that. So and there were very professors who took interest in my own development very early on. I mean, I remember my biology professor took me aside at the end of the final exam in year 2. And he said, "Have you thought about grad school?" I was like a second-year undergrad student, and I was like,
obviously, though, a compliment to you.
Exactly.
Yeah.
And I said, "Well, that's
Somebody
too
can
early.
see
I'm
your
in
future.
second year."
Yeah.
But it's like, yeah, you need to think about it from now. I said, "Wow, okay, well, thank you." And of course, year 3 comes, and I meet other professors who actually also say the same thing. And then I said, "Well, let me look into that."
Yeah.
So this is the type of mentorship. It's exposure to knowledge. It removes this barrier to knowledge. That really help you think about yourself in the future, not just within the limited time you spend with these professors.
But it's very individual. Like mentoring is very individual.
That's
it's
right.
forging a connection.
That's right.
It's creating a relationship, and that's how it works,
That's
right?
Absolutely.
But, you know, we don't always take the time to forge those relationships, right? Especially if you have a class of a whole bunch of people, right? But you're, you know, noting who is excelling in your class and then pursuing a relationship with them, that's really,
because I recognize that there is a power difference. Yeah. You know, and they might.
So you have to make the first move.
I have to make the first move. Yeah. You know, and I also extend the invitation for them to think about these issues, and if they have questions, to come to me. So I try to cover all bases.
Yeah.
You see what I mean? But there is always the hesitation because you're an authoritative figure. And there is this power difference, and there are students who just like to remain, you know, to themselves, which is a loss to the society. This is how I look at it. If we have talented people that have hidden potential, and that potential comes in their written work, in their oral presentations, and we miss them because we did not pursue, and this raw talent was not polished, that's a loss to society. They will find something, and they will, you know, they will have a good life, but they will still continue to be in their comfort zone. And our loss as a society is that we didn't capitalize on their strengths to help society move forward and to help science move forward. So that's how I look at it. It's really a matter of resources.
No, I completely agree with you. You know, one of the things that I worry about with my students, and I worry about particularly with respect to environmental problems, is that there's a lot of misinformation and disinformation out there, right? Circulating around in various, you know, areas, social media. How do you prepare your students to combat that? Like, do you talk to them about that, or, you know, how do you approach people? How do you discuss it? How do you get information out there? You know, I've been, especially recently, involved in these Facebook discussions where somebody will say something about climate change, and I come in just in a non-confrontational way and say, well, actually, you know, here's some information, and, you know, this is what the science says, and, you know, that kind of thing. But it's very hard to do that, right? In different spheres. Do you talk to your students about that?
Well, I try. We don't get to these nitty-gritty social media fights and arguments. Because I am myself not on social media. I really avoid these.
I think you're probably wise.
You know, avoid these areas. But what I really try to tell them is the importance of having knowledge to create a reputation as a trusted person, and that if you have opinions, these opinions need to be based on facts, and the facts are what the science provides, with the acknowledgement that this is the science of the day is telling us this, and the way we interpret it is the best way we can interpret it given the facts on the ground. And then think of the implications. Like, you need to move just beyond citing data into the implications. But then to think about implications, you have to have the necessary background. So at this stage, you know, because most of my students are undergraduate students, and for them, their thinking of big problems only come later in their education. In the beginning, they're just very concerned with finishing the course and getting a good grade.
Passing the next quiz.
to
Yeah.
get into
Yeah.
philosophical questions and societal problems. And it's like, well, but what my grade will be in the classroom? So it's just hard to bypass this,
The very present concern.
Exactly.
Yeah. Yeah.
Yeah. But definitely it is on my radar. And in the courses where I have this, for example, this second year class, it's full of undergrads who only had taken one chemistry course as a prerequisite, which is the general chemistry.
Right.
They are, after we spend, a few months together reading and analyzing and looking at documentaries, then they start, their mind starts to open up about the fact that, oh, these issues we're talking about are beyond the grade for a course. So, and then they start to ask smart questions, challenging questions, visionary questions, philosophical questions.
Yeah.
Yes.
All of the things that you're engaged with, right?
Mhm.
All of the activities. So, all your experimentation with
Right.
different forms of teaching and
Right.
learning, your mentoring, and then your service and your research. That's a very, very full agenda. How do you make that manageable and sustainable for yourself?
Time management.
Time management.
Absolutely
Yeah.
important. And priorities.
Yeah.
Setting up a priority for a semester, a priority for a month, um, and the fact that one has to schedule self-care, weekly. Do an activity that will just help you unwind and take your mind off.
Scheduling self-care, that just sounds somehow so wrong, eh? But I think you're absolutely right. Yeah.
You have to stick to it.
Yeah.
Otherwise, well, it can very easily eat at you. But then the other thing I recognize is that because I really want to excel in my teaching and the research and the service, I need to be my best.
Yeah.
And I found that when I actually allow myself the breaks I need, I become more efficient, have clarity of mind, energy level increases. So this is how I was able to overcome the feelings of guilt of taking time off. Is that because I come back better? You see what I mean? So this is why I schedule self-care, because I know that I need it. My mind needs time to unwind and to think and process, and then I come back stronger, more efficient, and with a clearer mind. So it's a win-win, And at the end of the day, when you prioritize your work and you manage everything according to the short and long-term um, deliverables you need to get done, then it becomes easier and manageable to swallow.
So you've already achieved so much. What's next on the horizon for your teaching? What do you want to try next?
I'd like really to increase opportunities for hands-on experiential learning. I'd like, I did this project with undergrads through outreach with local schools. And it was very well received, not only by the university students, but also by the school boards, the teachers, the principals, the students. And it was about air quality education, the science, the monitoring, the health impacts, what students can do at their homes and in their schools. And I thought that experience was transformational to the university students because it shows them how knowledge is applied to communities within weeks. So they've learned presentation skills, relationship building skills,
Sure.
delivering information that is accessible to different levels of people who are not necessarily chemists, chemistry majors like themselves. And I felt that, that experience within a short period of time is so invaluable that I'd like really to do more of it with the students down the road. And the other thing I found very helpful for research in particular, research students, undergrads or grads, is this exchange opportunities with scientists outside the university. Like I have a lot of collaborators in Canada and the US, and I did give this exchange opportunities to a few students I had in my group. They will go for a week, do the analysis in another lab. So they get to meet my collaborators, their students.
Wonderful.
Get to do science, bring data back, and they come back different people because they traveled. They ended up engaging in this relationship building exercise with people who have similar interests to their interest. So I'd like to offer more of those. So that's what I have on my radar for sure.
Okay, well that sounds great. That means we'll just have to have you come back at some point and talk about your new experiments.
That's good.
Great. Well, thank you so much. My thanks to Hind Al-Abadleh for joining me today, and I hope you will join me for more conversations that celebrate exceptional teaching practices, explore diverse teaching philosophies, and discuss the future of higher education and learning.